Hi guys, we're doing a lesson for 2.7, solving log equations. So in this section, we have two different ways that we can solve log equations. Either everything has a log, in which case you would use log laws to simplify, and then you would solve the arguments. That's the stuff inside the log. If you have something that doesn't have a log with it, then you simplify the logs that you have and you'll use your 7 rule to rewrite as an exponent and solve. Now we know that we can't take the log of a negative number. Never, ever, ever, ever take the log of a negative. So that means we have to check that our answers won't give us extraneous roots. This means we have to verify our solution. First example here, every single term in this equation has a log. So I'm going to use log laws to simplify until I just have one log on each side of the equation. In this case, that means this subtraction sign of two different logs is going to become the division of the arguments in one log. Now that I have a log on the left and a log on the right, I can drop those and solve the arguments. So what we have in the arguments is x over 2 equals 5. This next step is getting rid of the division of 2 by doing the opposite. So multiplying by 2 on both sides of the equation, canceling these ones to get x equals 10. Now, if I was teaching you this in class, I wouldn't be putting a box around this just yet. I need to verify that it won't give me extraneous roots. So I'm verifying over here in the original equation. So in this equation here, I'm putting x as 10. So this you can put into your calculator and make sure that left side equals right side. This is an important step to show in mathematics to show that you have in fact verified. Some of them are so simple that verifying you can do in your head, but then the person that's marking your work won't know that you actually went as far as to verify your answer. If it works out that left side equals right side, so you get the same decimal, the same number on both sides, then you put a box around it, that's your answer. Let's try the next one. Log base 5 of 3 plus log base 5 of x equals log base 5 of 30. First thing you check for, does everything have a log? Yes, this one does. So I'm going to use log laws to make this plus sign into the multiplication of the arguments. So 2 logs have become 1 by taking 3 and x and multiplying together. This side only had 1 log, so just bring it down in your work. Now that you have 1 log on each side, and the bases of the logs are the same, that's important, we can drop the logs and solve the arguments. So the log base 5 is going to go away, and we're going to get 3x equals 30. Solve using your basic algebra skills, divide both sides by 3, you get x equals 10 again, and then you're going to go ahead and verify that it works. So just by putting in your calculator, log base 5 of 3 plus log base 5 of 10, and making sure it's the same decimal as log base 5 of 30. Once you've verified, you can put a box around your answer. C is the first example we have where there's something without a log. So we see on the left side, both of these are log base 5. On the right side, we just have the number 1. So not everything has a log. We're going to use the steps of combining the logs that we do have with log laws. So again, addition of 2 logs becomes multiplication of the arguments in 1 log. That's the first step. And then we're going to use our 7 rule. Since this side doesn't have a log, we can't just drop this log. So you're going to see in this next step, 5 across the equal sign to the power of 1 equals all this stuff. Now what would you do back in 20-1 if you wanted to solve this? Well, you would have to expand this because we can only solve a quadratic if it's equal to 0. So I need to FOIL this. That's the answer when you FOIL it. and then I need to move the 5 over so I have a 0. Once I have a 0, I can solve this a number of ways. If I'm saying algebraically, I can solve it by either factoring or the quadratic formula. If I haven't said do your steps algebraically, you could put this in your calculator and find x-intercepts, but usually we want to see the algebra. So factoring for this one, since the numbers are nice, is the simplest way. We have multiplication to -8 and addition to -2. What two numbers multiply to give you -8 and add to give you -2? -4 and +2. When you factored that out into your brackets, you then have to use the zero product property to set each bracket equal to 0. Okay, once you do that, you'll add 4 to both sides and -2 from both sides to get your two possible solutions. Now this is where we have to verify, because if I put 4 back up here, I indeed get the number 1. If I put -2 in this one, -2 plus 1 is -1. We can never have an argument that ends up being negative. So this is a prime example of when you will have to cross it off and say extraneous root. It's very important for you to use the proper terminology here. We see lots of stuff when we give students these. We see no solution, we see answer doesn't work, impervious, we see all sorts of words. It's important that you know the word is extraneous and that you can spell it. Now, this one being extraneous doesn't mean that there's no solution. The solution that works is 4. It's right here. This is the answer. But this one happens to be extraneous. Now over here, when I taught this last time, I would have given an example of what you might see in multiple choice that can clue you in to checking for extraneous roots. You might see one option has 2 answers and one option has 1. That'll be a big clue to you that you need to check your possible solutions because one of them could be extraneous. Next example here. First thing we're checking for, does everything have a log? I see this number 1 does not have a log. So what I'm going to do is move this log to the other side so that I can get 1 by itself. The reason why I'm doing this is so I can apply my 7 rule later on. So this log is being added. I'm going to minus it to move it to the other side. Now I can combine these two logs. Subtraction corresponds to division. And then I'm applying my 7. 10 to the 1 equals all this stuff. How would I solve an equation when there's a fraction over here? Well, first things first is all of the x's need to be in the numerator. So this arrow here is showing you that I'm multiplying x plus 1 over here. That means that 10 is multiplying through the distributive property to x plus 1. The numerator stays on the other side of the equals. Here's my distributive property done, and now I've got some basic algebra of collecting all of my x's onto one side. So I minused 8x over here. 10 minus 8 is 2. And my numbers are going to go to the other side. So minus 10 from 4, and you get -6. Divide both sides by 2 to get x by itself, and you get -3. Now, just because this answer is negative doesn't mean it's extraneous right away. The only way you figure out that it's extraneous is by putting it back into your original question. So if I put a -3 right here and add 1, I get a negative argument. So again, extraneous root. And this is the option, this is the opportunity where you actually do have no solution to this because there wasn't another option that we got from the quadratic formula, for example. So this is a perfectly fine answer in this case. Before, it would be inappropriate to say no solution because the solution is sitting right here. Now, if this was my work, I would probably put a box around no solution. That's ultimately your final answer. There is no x value that can go into this equation and make the left side and the right side equal. All right, in this set of notes, I have an example of what not to do and what to do. So in this first example, we can see that the exponent of 2 was brought in front, divide both sides by 2, apply the 7 rule, and solve. That gave us one solution. Over here, what's happening is we apply the 7 rule first. 2 to the 4 equals x plus 3 squared. Squaring a bracket is repeated multiplication. I'm going to FOIL, move the 16 over, and refactor when I have it equal to 0 to get my two solutions. When you bring the 2 in the exponent out in front like this, you get rid of this repeated multiplication that's actually happening. So when you have exponents, the important thing to remember is not to bring it out in front like this. If I were to graph this, when I do it this way, I'm only getting one solution. And if I do it this way, there's actually two different solutions that I'm able to find. Now, this is a good example of when your answer is negative, but that doesn't mean it's extraneous. If I put negative 7 back into the original question, negative 7 plus 3 is 4, negative, and then I square it. So a negative number squared becomes positive. That's why this is a perfect solution, because a negative becoming positive does not violate our argument never being negative. All right, check your logs. Does everything have a log? This 3 is not a log, so we need to move this log to the other side by adding it. Then we can perform our log law. Addition becomes multiplication. 7 rule is next. 2 cubed is all of this stuff. And you can jump some of these steps. If these are grade 10 things that you're doing, like foiling, and you know how to do that because we practiced it, you don't have to show all of the steps of combining like terms. Some of you might be able to do this in your head. This is an 8, and minusing 8 will give us 16. Once we have a 0, we can go ahead and factor. The numbers that multiply to 16 and add to negative 10 are negative 8 and 2. Remember that you can only jump to these factors if the leading coefficient is a 1. If it's not a 1, you have to do the full decomposition method of factoring. And then to state the solutions, you're simply switching this sign. So positive 8 and positive 2. These need to be verified. You'll want to show that in your work. And when you put 2 here, 2 minus 6 is negative 4. That's extraneous. Put an 8 here and make sure that it gives you left side equal to right side. One more example. Everything has a log. This is where we're back to combining with log laws and dropping the logs. So we have plus, that turns into x times x minus 1. This side was only one log, so just bring it down. Log 7s on both sides means they can cancel. And you get x multiplying in, so x squared minus x equals 4x. As soon as you see an x squared, you're thinking quadratics, so you're moving the 4x over so that you have a 0 and you can factor. The factoring of a binomial like this is GCF. Remove the x, and you're left with 1x minus 5. This x in front, don't forget, when you're setting these equal to 0, this gives you a possible solution of 0. This one, you switch the sign, positive 5. Check both and see if they work. The 0 is going to give you an extraneous root. I suggest that you write that word every single time. You can write root, you can write solution, you can just write extraneous, just write the word. and this one has one solution of 5 that works. So here's your textbook questions to practice. If you have any questions, let me know.